A potential difference of 10 volts is applied between the plates of a square parallel plate capacitor with a side length of 0.05 meters and a plate separation of 10 to the negative fourth meters. Find the energy stored. So here's what we know. First, U is going to equal to the energy storage, which is 1/2 QV, which is equal to 1/2 CV squared, which is equal to Q squared divided by 2C, where Q is the total charge, V is a given voltage, and C is capacitance. Now these are parallel plate capacitors. So we have the parallel plate capacitance formula, where C parallel plate capacitor is equal to K multiplied by epsilon 0 A over D, where A is equal to the total area of each plate in the parallel plate capacitor, and where D is the distance between the two plates. The value of K when you're going through air, K is the dielectric constant, the value of K when you're going through the air is approximately equal to 1, and E0 is approximately 8.9 times 10 to the negative, I just want to make sure I have that right, is times 10 to the negative 12. Now, let's get to solving this problem. First thing we have to do is we have to find the capacitance value so we can plug it into the energy storage value. So we have C parallel plate is equal to K epsilon 0 A over D. So with our problem up here, we know that the side lengths of each of the parallel plate capacitors is 0.05 meters. And we know that this is a square parallel plate capacitor. So we know that each of the plates in the parallel plate capacitor are square. So we can say that the side lengths for each of these are going to be equal. And that the area, so then A is equal to the two sides multiplied by each other, or the sides squared. So A is equal to 0.05 meters squared, which should be equal to, if we plug that into the calculator, should be equal to 0.0025 meters squared, because it's an area. Then from there we need to plug it in to find our capacitance of our parallel plate capacitor. So we have K epsilon 0 A over D. We know that our D is going to be the plate separation of 10 to the negative 4 meters, which is listed right here, which is small. So that's going to be our K value, which is 1. So C parallel plate is equal to 1 multiplied by our epsilon 0 value, which, as we know, is approximately 8.9 times 10 raised to the negative 12. Of course, that's then multiplied by, oh, there go the expo markers, multiplied by A over D, where our A value is our area, which is 0.0025 meters squared, divided by the distance between the two plates, which is our plate separation, which is 10 to the negative fourth meters, as stated right there. Negative 4. So then if we plug that into our calculator, times 10 raised to the negative 12 multiplied by 0.0025 divided by 10 raised to the negative 4. We should get a value of 2.225 times 10 to the negative 10, which, if we're rounding to two significant figures, it should come out to 2.23 times 10 raised to the negative 10. That's going to be our capacitance. So now we have our capacitance. We need to find our energy storage. So based off the information of the problem, we can plug it into this U, is equal to our energy storage equation, and based off of what we have 10 volts right here, which is given as the potential difference, and we have a capacitance value. They don't give us any information about charge. I guess we could hypothetically solve for it. But it would just probably be easier if we plugged it into this 1/2 CV squared formula. So then we have U, which is equal to 1/2 C V squared, where C is our capacitance and V is our voltage. And so that's going to equal to 1/2 2.23 times 10 to the negative 10. It's going to be multiplied by V squared. And our V value is a 10, and 10 squared is going to be 100. So this is going to be multiplied by 100, which is a 10 volt squared. So then if we multiply this all out, where we have 1/2 2.23 times 10 raised to the negative 12 multiplied by 100, we will get a value which should be our final answer of 1.115 times 10 to the negative 10, which if you go for two significant figures will be 1.12 times 10 raised to the negative 10, which should be our final value. And of course, then there's the energy unit, which I believe are joules. I just want to check to make sure real quick.